Welcome to the video. So today we are going to solve another Math Olympiad problem. So this 8-digit number 85A32B63, if it is divisible by 99, then we have to find A and B. This is one of the number theory problems where the concept we have to learn is about divisibility by another number. So let's get into it. So two concepts. As we know, 99 is 9 into 11. So when this number is divisible by 99, it will also be divisible by 9 and 11 individually. So the two concepts that we need to learn is about divisibility by 9 and divisibility by 11. So two concepts that we need to learn here are, first is divisibility by 9, where what we are looking for is the sum of all the digits in that number is divisible by 9. So in this case, 8 plus 5 plus A plus 3 plus 2 plus B plus 6 plus 3 should be divisible by 9. And the second concept is divisibility by 11. So what it says is sum of even placed digits minus sum of odd placed digits should be either 0 or divisible by 11. So those are the two concepts that we need to learn here. Okay, so let me erase this. Okay, so from concept 1, which is divisibility by 9, 8 plus 5 plus A plus 3 plus 2 plus B plus 6 plus 3. This should be divisible by 9. So 8 plus 5 is 13, 13 plus 3, 16, 16 plus 2, 18, 18 plus 6, 24, 24 plus 3, 27. So this is 27 plus A plus B. And this has to be divisible by 9. So we know that 27 is divisible by 9. So we can remove this. Now we have to find A plus B, which should be divisible by 9. So A plus B, because these are single digits, they can be either 0 or 9 or 18. Correct? In the case of 0, A is equal to 0, B is equal to 0. That is case 1. In the case of 9, A plus B is equal to 9. In the case of 18, A is equal to 9 and B is equal to 9. That's the only possibility here. That's the only possibility here. But here A plus B is equal to 9. Okay, now let's go to the concept 2, which is divisibility by 11. So we have to now do a alternate addition and subtraction. So 8 minus 5 plus A minus 3 plus 2 minus B plus 6 minus 3. So this number should either be equal to 0 or divisible by 11. Let's see, let's count this. So this is 3, 0, 2, 8, 5. So A minus B plus 5 should be either 0 or divisible by 11. If A is a single digit number, B is a single digit number, then A minus B can vary from minus 9 to plus 9. Let's see from here what we can do or what we cannot do. If A and B both are 0, then 5 cannot be equal to 0. So this we can eliminate. If A is 9 and B are 9, if both are 9, then also this becomes 0, then 5 cannot be 0. So this we can eliminate. And next is A plus B is equal to 9. Let's say if this is equal to 0, right? So then A minus B is equal to minus 5, case 1. So 2A, if we add these two together, will be 9 minus 5 will become 4. So A is equal to 2 and then B is equal to 7. Oh, okay. So we got one answer here. Okay. Now let me erase this. So what we have is, based on this equation is equal to 0 and A minus B is, A plus B is 9 and A minus B is minus 5. We have A is equal to 2, B is equal to 7. Now let's consider the other case where we know that A plus B is equal to 9. For case 2, A minus B plus 5, let's say 2 should be divisible by 11. So let's take case 2A where this A minus B plus 5 is equal to 11, and case 2B will be A minus B plus 5 equal to minus 11 or 22. So let's see whether this is possible. So we have to subtract A minus B and then we have to add 5 such that this becomes minus 11. The lowest value that A minus B can have is minus 9. When you add 5 to it, it will become minus 4. So we cannot have this number. The other highest value A minus B can have is 9, because A is 0 to 9, B is 0 to 9. 9 plus 5, the maximum it can go to 14. So this also is ruled out. So only this case will remain. So I will erase this. So let's say if we have A minus B plus 5 is 11, that means A minus B is equal to 6. And we know A plus B is equal to 9. So then if we have to add them up, so we get 2A is equal to 15. And that means A is 7.5, but which cannot happen. So the only answer that we have is A is equal to 2 and B is equal to 7. So that's our answer. Hope you like this video.